This video is for section 6.1. It's the first part of the lesson, counting with combinations. At the end of the lesson, you should be able to count the number of possibilities using combinations, and we are going to be learning a special formula for using and counting combinations. We're also going to be learning how to use our TI-83 calculator to calculate a total number of combinations as well. So let's take a look at this first example here. Tony's Tasty Pizza offers pepperoni, ham, sausage, onions, olives, and mushrooms as toppings that you can put on a pizza that is part of a temporary promotional price. Suppose that you want to order a 2-topping special pizza. How many ways can this be done if you do not select a double topping of any type? So in other words, you can't choose double ham or double sausage or double of any of these items. So how many ways? That's what you're always looking for in terms of how many combinations of ways can you put together these toppings on a pizza. Well, most pizza places have way more toppings than this, but it's nice that we have it narrowed down to just 6 toppings. Okay, so we have 6 toppings to choose from, and we want to know how many different pizza combinations could we have that have 2 toppings on each pizza. Well, let's start by noticing that we are using a total number of 6, but we're only going to be choosing 2 for each pizza. So if I start off and I say, well, if I have pepperoni, I love pepperoni, I have to have it, and here's one way that we can combine with pepperoni. We could have pepperoni and ham. We could have pepperoni and sausage, or pepperoni and onion, or pepperoni and olive, or pepperoni and mushroom. Okay, so how many different combinations is just this grouping right here? Okay, just starting with pepperoni. Well, that's 5 different ways that we can put pizzas together. Okay, so now if we start again with a different starting item, let's start with ham. And of course, we can't include pepperoni because that would be just like this one over here that we just made. So if we start with ham, we could also include a combination of ham and sausage, ham and onion, ham and olive, or ham and mushroom. Now, if we count those up, that's 4 different ways, right? We have 5 from when we started with pepperoni. We have 4 when we started with ham. Now let's start with sausage. We can't have sausage and ham and sausage and pepperoni because we already did both of those in the previous one. So we're just going to keep working down the line here. We could have sausage and onion. We could have sausage and olive. We could have sausage and mushroom. And that is 3 more combinations of pizzas that we've designed. What if we had onion? Well, onion could go with olive or mushroom, and that is 2 more ways that we could design a pizza. And then our final, last one is going to be just olive and mushroom. Okay, so that's 1 more way. So if I add up all the numbers I have here in the black ink, 5 plus 4 plus 3 plus 2 plus 1, that is a total of 15 different pizza combinations from just the 6 toppings that I started with. You can imagine that this would take a lot more time if I had more things to choose from or more things that I would choose. So if I was choosing more toppings or I started with, more options of pizza toppings, it would take me a lot longer to find all these combinations. So we want to come up with a shortcut, and the shortcut that we can use is going to be a specific formula that I want to use with you. But before we get the formula on the screen, I'd like to write down the definition of combinations. Okay, and here we have the definition of combinations. It's the number of groups of R items. We're going to represent the number of items we're choosing with the letter R from N total objects when order is not important. And these N's and R's come from the formula. So let's go ahead and write down the formula. The formula says n factorial, and I'll explain that in just a moment, over r factorial times the difference between n and r factorial. Okay, so here's the formula that's important for you to know. If you don't have a calculator, you can always use this formula, and we'll have this posted in the classroom as well. So it's important to remember from what we're talking about here is n is the total number of objects. So on the top, you're going to write in the total number of objects given to you in the problem, factorial. Factorial means to multiply the number by every positive integer less than the number that has been given to you. We're going to do an example of it in just a moment. Then the R, remember R is the items, the number of items that you're choosing from the total objects. Just like we did with our pizza creations, we had 6 objects to choose from, right? We had 6 of them to begin with, but we were only choosing 2 of them. So in this case, n would be represented by 6, and r would be represented by the 2. So what I would like to do is I would like to plug in the information into our formula. We already know when we did this by hand before we knew the formula, there were 15 combinations. Let's check and see if our formula gets us the same answer. Okay, so we know that n is 6. But what does this factorial mean? It means that we have to multiply 6 by 5, by 4, by 3, by 2, and by 1. So we have to multiply the number that is n by every positive integer beneath or less than that number. All right, what is our r? Well, our r is 2 because there were 2 toppings that we were choosing for each time. So that's going to be 2 times 1 because 1 is less than 2. And then we also need to do what is n minus r? N is 6 and r is 2. So that means that we have to use 4 times 3 times 2 times 1 as well. Okay, so this is a lot. I know that it's a lot, but just stick with me. So now we have this multiplication problem to do, but we can cancel some things because 1 over 1 can be canceled, 2 over 2 can be canceled, so can this, so can this. So we're simply left with 6 times 5, which is 30, and 2 times 1, which is 2. 30 divided by 2, voila, is 15. So we're going to try some more of these. One of the things that we have in this box right here asks us, is the order of the items important? Okay, so when we're doing combinations, order is not important. Can you repeat items? No, you cannot repeat items. Okay, so just like we were talking about, there cannot be double ham or double sausage on your pizza, so you can't have 2 of the same thing in the group. All right, so let's take a look at example number 2. These are some different formats that you're going to see when you're working with combinations. So when you're working with combinations, you might see something in this form. The 8 is representing the n. Okay, the n is on the left of the big C, and the r is going to be the 5. So that means that we have 8 total objects, and we're choosing 5. So in other words, we have n, capital C, r. And that's what you should think of each time you see that, is that we're taking 8 objects and we're choosing 5. So to use my formula, I'm going to write this out. I'm going to say that I have 8 total objects, so that's going to be my n factorial over r factorial, which is just 5 times 4 times 3 times 2 times 1. And then don't forget that we have to subtract n minus r. So 8 minus 5 is 3, and we have to multiply that factorial as well. And I can cancel some things here. I'm going to cancel this 5 with this 5, this 4 with this 4, and so I need to multiply these things that remain to find out how many groups can be made from these 8 objects. And there are 56 total. So I used my calculator, I multiplied 8 times 7 times 6, and I got 336, and then 3 times 2 times 1 is 6, made the division, and I got 56. So I would like you to try part B on your own, and I would like to look at problem C of example 2. So how do we read this? Well, we read it that we have a total number of objects n, and we're choosing one of these objects, so that's going to represent r. So n choose r here is going to be 4 choose 1. N, choose, R is how we read it, but it's going to be 4, choose 1 specifically for this problem. So again, I'm going to take my n factorial, 4 times 3 times 2 times 1, over 1 factorial, and then I also have to subtract the 2. 4 minus 1 is 3. 3 times 2 times 1. Cancel the things that are alike, and I'm left with just 4 over 1. And so there are a total of 4 ways to make combinations choosing just one item from the 4 items that we started with. So again, we want to remember that n is the total number of objects, and R is how many objects you're choosing. Please do part D on your own as well. All right, I would like you guys to try example 3 on your own. It's going to be similar to the one that I'm going to do here as example 4. When playing the Michigan lottery game called Lotto 47, a person gets to select 6 different numbers between the numbers 1 and 47. How many different sets of 6 numbers are possible? So what's the total number of balls or numbers that you can choose from? And this is going to be our n. 47 different numbers can be selected from, but R is going to be 6 because we're only choosing 6. So could I set this up in my formula? Absolutely. 47 factorial over 6 factorial, and then 41 factorial because I have to subtract R from n. The other thing that I could do is I could get my calculator, and there is a factorial button. I can show you where that is when we get to class. But we also have another way to do this on your calculator, so I'd like you to write this down. The steps to do this on the calculator is, first of all, you want to type in 47, and then you want to touch the math button on your calculator. And then you want to go all the way over to the right. You'll see a menu, and it will say PRB. That's the probability menu, so go ahead and hit that. Then when you're in the probability menu, you want to choose the number 3, and it's going to look just like this, N, capital C, R. So you should be familiar with that because we're dealing with combinations, which is what C stands for. N is our 47, which you've already entered, and then you want to choose the number 6 because you want R to represent 6. Now, on your calculator screen, you're going to see 47, NCR, 6. And once you hit enter, the answer will automatically pop up on your screen, 10,737,573. So when you go to do example number 3 on your own, the least you could do is set up this problem. Okay, so set it up. What are the total number of objects you're choosing from, and what are the total number of choices that you're making? Okay, so at least set it up, and when you get to class, you can use a calculator and try out these steps right here to help you find the answer easier. In some of the combination problems, you're going to see the word and you may also see the word or. We're going to practice these types of problems here on this side of the paper. Counting using addition or multiplication of combinations. When you see the word and, or the word and is implied when you're reading it, you want to remember that you have to multiply. So and means that you want to do multiplication of combinations. If you see the word or, you want to remember that that's going to be an addition problem. Okay, so addition of combinations. So let's go ahead and give this a try. In example 5, it says that there are 25 students in a class. There are 10 girls and 15 boys. I plan to randomly call on 4 people to come up to the board to answer a warm-up question. How many 4-person groups are possible if? Now you saw this problem in example number 3. However, this time we're being a little bit more specific about the groups. We're saying we want 3 boys and 1 girl. Now the word and, remember, means multiply. So once we find out the total number of groups we can have with 3 boys and the total number of groups we have with 1 girl, then we're going to multiply them together. Okay, so in our case, for boys, we're using n is 15 and r is 3. Where did I get 15? Well, there was a total number of 15 boys, and we need 3 of them in our group. So you can use your calculator, and for 15, choose 3. There are 455 different groups that I could come up with. And when we're looking for girls, number of girl groups, n is 10 because there were 10 girls total in the class. We only need 1 girl in each group, and therefore there are 10 total ways that we could come up with those groups. So what I need to do now is I need to multiply the 10 times 455, and that is a total of 4,550 different groupings of 3 boys and 1 girl. And I would like you to try this problem on your own. Notice the word and is still here, so you're still going to be multiplying. The difference is that you're going to have groups of 2 girls and 2 boys. And remember, the total number of girls was 10 and the total number of boys was 15. Again, when you're doing this on your own, at the very least, set the problem up so that when you get to class, you can actually use the calculator to find out the total number of combinations. All right, so for example 6, it says that William Shakespeare wrote 38 plays that can be divided into 3 genres or categories of plays. Okay, so some of his plays were comedies. 18 of them were comedies of the total 38 plays. N is going to be represented by 38. 18 are comedies, 10 are histories, and 10 are tragedies. So in part A of this example, it says, suppose that you plan to read 2 or 3 plays, so regardless of their genre. The word or here, remember, is going to mean that we have to add the combinations. How many different ways can this be done? How many different ways can we come up with that you could read 2 or 3 plays? It doesn't matter what the genre is. So if we read 2 plays, that's 38, choose 2, plus if we read 3 plays, that's 38, choose 3. So in your calculator, you would be entering, remember you would enter 38, then you would make the NCR appear on your screen, and then you would put in the 2. And there are 703 different combinations that you could come up with when you're choosing 2 of any of his plays from the 38. Plus, if you're choosing 3, then that means that you would be having 8,436 different ways to choose those 3. And that is a total of 9,139 different combinations of 2 or 3 plays of his 38 plays. And remember, order is not important. It does not matter. So that's why there are so many different ways that you can read those different things that he wrote. Now, in part 2 of this example, we want to suppose that you plan to read 2 comedies and 1 tragedy that William Shakespeare has written. I know that you probably noticed already that the word and is here, and we want to multiply the combination of 2 comedies against the combination of 1 tragedy. So we're looking for how many different ways can we do this. And remember, there were specifically 18 comedies, all right, 18 comedies, and there are 10 tragedies. So when we have 18 total comedies and we're choosing 2, we can find that out, how many combinations of those there are. And then we have 10 tragedies and we're only choosing 1. Okay, remember, we're going to multiply these together because we see the word and. For 18, choose 2. There are 153 combinations. And for 10, choose 1. There are 10 combinations, and so that means that we have 1,530 different ways that you could come up with 2 comedies and 1 tragedy. All right, let's take a look at example 7. It says, in the Powerball lottery game, you get to choose 5 different numbers from numbers 1 through 59, and notice that this says and, which means multiply. You also get to choose one number from this set of numbers. So there are 35 to choose from. How many different combinations are possible? So what I would like you to do is set up the first thing times the second thing. Remember, you're looking for the total number over R. Okay, so you're going to read this again, looking for the total number you're choosing from the total number of numbers that you have to choose from. All right, and when you get to class, you can use the calculator to try out the NCR option. And I'd also like you to try example 8. During the school year, the girls' basketball team is scheduled to play 11 home games. You want to attend 3 or 4 of them. Remember, the word or means that we have to add. So what I'd like you to do is set up the first choice, and then of course you're going to add the second combination, and then that's going to give you a total. So read through this question again and set this up, because the number N is the total number of objects that goes on top, and R is the number of items you're choosing from the total number. So if you have some questions, please make sure you ask them in class, and we will be practicing some more problems like these in class as well. Thanks for watching.